Hello friends, Mr. Burrell here. We're in Unit 6 talking about properties of exponents, different expressions that have exponents in them. We talked about the product and the quotient rules when I'm like multiplying exponents with the same base, dividing exponents with the same base. Today we're going to talk about negative exponents and the power rule. So, by the end of class today / by the end of this video, these are the things that I hope you're able to do. I want you to be able to use rules associated with negative exponents in simplifying exponential statements. Use rules associated with zero exponents in simplifying exponential statements. And simplify exponential statements taken to a power. We'll talk about those. So, if you have one of the calculators like we used in class, there's some helpful commands in the calculator that are going to be helpful with some of the things we do in this section. Specifically, this button for putting in an exponent. When entering in a fraction, you can enter the fraction like this, like 1/3 written as a fraction in your calculator. Could be written as parentheses 1 divided by 3, close parentheses. The calculator will treat it as a fraction. And then once you have a decimal, you can convert a decimal to a fraction by clicking Math, Enter, Enter. So when you click the Math button on your calculator, it pulls up a fraction option, and you push Enter, Enter, and it'll convert it into a fraction. If you don't have a calculator like this, there are similar commands in other calculators, or like if you're using Desmos, or some online calculator like that, there will be similar commands as far as utilizing exponents and fractions and things like that. So what I have is I have a bunch of different pretty simple exponential expressions, and what I want you to do is write down what the decimals are for each of these exponential expressions, and then down here what the corresponding fractions would be. So for example, 2 to the 1 power, if I type that in my calculator, I get 2. 2 to the negative 1 power in my calculator, I get a 0.5. 2 squared, or 2 to the second power, comes out to be 4. 2 to the negative 2 power ends up being 0.25. And if you type in 2 to the 0 power in your calculator, you get 1. So if I write all those as fractions, so 2 is just 2, 0.5 is going to be 1/2. 4 is just 4. 2 to the negative 2 is 1/4, if you write that as a fraction. And then 2 to the 0, again, is just 1. So something I want you to notice, especially like right here. So 2 squared was equal to 4. And 2 to the negative 2 is equal to 1/4, or 1/2 squared. See that? So 2 squared was equal to 4. Sorry, let me write this over here. 2 squared was equal to 4. And 2 to the negative 2 was equal to 1/4, or 1/2 squared. Notice what happened to my exponent here. Notice what happened there. Note that when I had this negative exponent, it really translated to just having a positive exponent in the bottom. It kind of flipped over the line and the sign changed. So 2 to the negative 2 is the same as 1/2 to the positive 2. 2 to the negative 1 is 1/2 to the positive 1. See that? So if I had like 3 to the negative 3, that would be equal to 1/3 to the positive 3. If I had 7 to the negative 17th, that would be equal to 1/7 to the positive 17th. Okay? So when I have negative exponents, I flip the line and change the sign. One other thing, notice that with 2 to the 0 power, I got the number 1. Test something out in your calculator. Test type in this, 1, 2, 3, 4, 5, 6, 7, 8, 9, to the power of 0. Type that in your calculator, see what you get. When I take that to the 0 power, I get 1. So anything that I take to the 0 power is going to be equal to 1. So when I have negative exponents, well, let me go on to this next section. So now I have some negative and 0 exponents, except without any numbers. I just have variables. So how would I write these expressions without any negative exponents? Well, x to the negative 2, I just determined that if I have a negative exponent, I could write this as 1/x to the positive 2. So the negative 2 exponent in the top switched to the bottom. X to the negative 3 turned into 1/x to the positive 3. The negative exponent in the top, or the numerator, moved into the bottom, or the denominator, and changed signs. 1 over x to the negative 5, that negative 5 is going to come into the top, so same going backwards. If I have a negative exponent in the bottom, it's going to flip the line and change the sign, so this is going to turn into x to the 5th on the top and just 1 on the bottom. 1 over x to the negative 1, that's going to be x to the positive 1 over 1. The negative exponent moves into the top. And then x to the 0, what's anything to the 0 power? Just 1. So I'm going to talk about this, and then I'll go back to that other slide. So the general rule with negative exponents is to flip the line and change the sign. If I have negative exponents in the numerator, they're going to move to the denominator, or into the bottom of the fraction. If I have negative exponents in the denominator, they're going to move to the numerator, or into the top of the fraction. When I take anything to the 0 power, the answer is 1. So negative exponents are going to flip the line and change the sign. 0 exponents are going to change the answer to equal 1. So let me show you some examples. So like, say, x squared divided by y to the negative 3. This y to the negative 3, that negative exponent is going to flip the line and change the sign. So y to the negative 3 comes into the top and becomes y to the positive 3. X to the second power, that already had a positive exponent, so it's not going to go anywhere. It's just going to stay up there. Here I have 2z to the negative 3 power over x to the negative 2 power. Well, this exponent is negative, so it's going to move to the bottom, flip the line, and change the sign. This negative exponent is going to flip the line and change the sign. So notice now this z to the negative 3 now turns into z to the positive 3 in the bottom. This x to the negative 2 turns into x to the positive 2 in the top. And this 2, I mean, it didn't have any exponents on it, so it's just going to stay exactly where it is. And then with 0 exponents, say I had 4 times x to the 0 times y to the 0. Well, x to the 0 is equal to 1, right here. Y to the 0 is equal to 1. Anything to the 0 power is equal to 1. So 4 times x to the 0 times y to the 0 is the same as 4 times 1, which is just 4. So negative exponents flip the line and change the sign. 0 exponents, anything to the 0 power is equal to 1. Okay. So, now we're going to move on to talk about the power rule. So when you take something to a power, just as a reminder, when I take something to a power or an exponent, that number, the number that's the exponent, represents how many times you multiply the base by itself. So for example, like 3 to the third power, or 3 cubed. That's the same as 3 times 3 times 3. An exponent just tells me how many times I multiply the base by itself. X to the third power would be x times x times x, 3 times. Sorry. Xy to the third power, since this is in parentheses, that whole thing gets multiplied by itself 3 times. So xy times xy times xy. X to the third to the fourth power, see that? What's in the parentheses to the fourth power just means x to the third times x to the third times x to the third times x to the third 4 times. Okay? So I want you to notice something here. On this problem right here, now that I've kind of written it out, xy times xy times xy, I could write that as, well, I have 3 x's being multiplied by each other, which is x cubed. I have 3 y's being multiplied by each other, which is y cubed. So xy cubed is the same as x cubed y cubed. Notice here, x to the third to the fourth power, I have x to the third times x to the third times x to the third times x to the third, which really I could write as x times x times x, times x times x times x, times x times x times x, times x times x times x. 3x's times 3x's times 3x's times 3x's, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I could write that as x to the 12th power. Notice here the relationship with what I started with and what I ended with. X to the third to the fourth power became x to the 12th power. Notice what I did to these exponents, you see? What did I do to 3 and 4 to get 12? I multiplied them. X to the third multiplied by itself 4 times. I multiplied those exponents together. I got x to the 12th. So let's take a look at this. So I have 2 squared to the 2nd power, which is the same thing as writing 2 squared times 2 squared. Well, each of these 2 squares is the same as writing 2 times 2 and 2 times 2. And 2 times 2 times 2 times 2, that's 1, 2, 3, 4 of them. So I could really rewrite that as 2 to the 4th. 3 squared to the 3rd power is just the same as writing 3 squared multiplied 3 times. And then each of these is 3 times 3, 3 times 3, 3 times 3. So I end up multiplying 3 by itself 6 times. 3 to the 6th power. Notice the relationship between these exponents and my final answer's exponents. See what's happening? See what's going on? X to the 3rd squared is the same as writing x to the 3rd multiplied by itself 2 times. And each of these x to the 3rds can be written as x multiplied by itself 3 times. So I have x times x times x times x times x times x for a total of how many x's? 6 of them. So x to the 3rd to the 2nd, or x to the 3rd squared, I can write as x to the 6th. Again, notice what I did with these 2 exponents to get to my final answer exponent. Okay, that's the power rule. When I take a power to a power, or an exponent to another exponent, I multiply the powers together. I multiply the powers together. So like for example here, I had 2 squared to the 2nd power. I multiplied those powers together and got 2 to the 4th. 3 squared to the 3rd power, I multiplied those powers together and got 3 to the 6th. X cubed to the 2nd power, I multiplied those powers together and got x to the 6th. So that's kind of a handy way to remember when I take a power to another power or an exponent to another exponent, I multiply them together. So let's do some examples real quick. So we're going to kind of combine both these last lessons that we've had to solve some of these problems. So here I have 3v to the negative 2 over 3v times 2v to the negative 4. So, my first gut feeling here is I am going to take a look and see if I have any negative exponents, which I do. That's my first step. Do I have any negative or 0 exponents? Well, what do I do when I have negative exponents? I flip the line and change the sign. So, I'm going to rewrite this. The 3 hasn't moved. This 3v hasn't moved. This 2 hasn't moved. But this v to the negative 2 flips the line and changes the sign. So this is times v to the positive 2. This v to the negative 4 moves to the top and changes to v to the positive 4. Okay? Okay, well now I want to simplify this expression as far as I can. So let me rewrite this out again. 3 times v to the 4th is 3 times v times v times v times v over 3 times v times 2 times, and then v squared is v times v. So now I'm going to say, is there anything I can cancel out on the top and on the bottom? Well, the 3's can cancel out. These v's can cancel out. These v's and these v's can cancel out. So what am I left with? V on the top, 2 on the bottom. So all of that simplifies to v on the top, 2 on the bottom. V over 2. Okay? Okay, let's take a look at this one. 2x to the 4th times y to the 3rd squared. So remember, all of this is in parentheses to the 2nd power, which means really this is 2x to the 4th y to the 3rd times by 2x to the 4th y to the 3rd. 2 times, sorry. Well, 2x to the 4th y to the 3rd times 2x to the 4th y to the 3rd can be written as 2 times x times x times x times x times y times y times y times 2 times x times x times x times x times y times y times y. Yeah. Well, 2 times 2 is 4. How many x's am I multiplying together? 1, 2, 3, 4, 5, 6, 7, 8 of them. So I have x to the 8th. How many y's am I multiplying together? Well, I have 6 of them, so that's y to the 6th. So I have 4x to the 8th, y to the 6th. That would be my final answer. You notice that if I go back up here, 2 squared is indeed 4. X to the 4th squared, if I multiply those exponents, I get x to the 8th. Y to the 3rd squared is y to the 6th. So I multiply those exponents. Okay, let me erase this and I'll do a few more. 2r to the 0 power divided by 2r times 2r to the 3rd power. Well, first thing I want to double check is, do I have any negative or 0 exponents? Well, I do have a 0 exponent here. R to the 0 power, well, that's the same as 1. So this is really 2 times 1 over 2r times 2r to the 3rd. Well, that's nice. 2 times 1 is just 2, so I have 2 over 2r times 2, and then r cubed is times r times r times r. Anything that can cancel out in the top and in the bottom? Some 2's can. So when everything cancels out in the top, I'm left with just 1 in the top. And on the bottom, I have 2, and then 1, 2, 3, 4 r's, so 2r to the 4th. 1 over 2r to the 4th. Okay, let's do a couple more. This one says 4ab to the negative 3 and 4b to the 4th times 2a to the negative 2. First, do I have any negative exponents? Yes, I do. B to the negative 3 and a to the negative 2, well, those are both going to flip the line and change the sign. So I have 4a, that hasn't changed. 4b to the 4th times 2, that hasn't changed. But the b to the 3rd changes signs and comes down here. And then a to the 2nd. This is going to go to the top and change signs. This is going to go to the bottom and change signs. Okay. Well, this is, I can write this as 4 times a times a times a and then a squared. On the bottom I have 4 and then 4 b's, 1, 2, 3, 4 times 2 times 3 b's. Anything that can cancel out in the top and in the bottom? The 4's can. Nothing else can. So I'm left with a cubed on the top, a cubed on the top. On the bottom, I have a 2, and then 1, 2, 3, 4, 5, 6, 7 b's. So my final answer would be a to the 3rd over 2 times b to the 7th. Okay, let's do one more. Negative 3x to the 3rd, y to the negative 4th to the 3rd power. This is all in parentheses to the 3rd power. So first and foremost, to the 3rd power means I'm multiplying it by itself 3 times. So negative 3x to the 3rd, y to the negative 4th, times negative 3x to the 3rd, y to the negative 4th, times negative 3x to the 3rd, y to the negative 4th. Okay. Well, if I multiply all of these together, now I'm going to be looking for negative and 0 exponents, which I have a few right here, see? So I'm going to rewrite this as negative 3x to the 3rd times negative 3x to the 3rd times negative 3x to the 3rd divided by, and then in the bottom, if I flip all those negative exponents to the bottom and change the signs, I have y to the positive 4 times y to the positive 4 times y to the positive 4. Okay. So you're hopefully starting to notice some patterns here. So if I write this all out on the top, I have negative 3 x cubed is times x times x times x times negative 3 times x times x times x times negative 3 times x times x times x. All over y times 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 y. 4, 8, 12. There's 12 of these. 3, 6, 9. There's 9 of these x's. So you kind of notice I wrote all of them out. I wrote all the x's and y's out. But again, remembering what I know about multiplying exponents with the same base, I could have just added all these together. 3 plus 3 plus 3 is 9. 4 plus 4 plus 4 is 12. Okay, let me write my final answer up here. So with my numbers, I have negative 3 times, this should be a negative 3 times negative 3. Negative 3 times negative 3 times negative 3 is negative 27. And then the top there, I have 9 x's, so x to the 9th, over 12 y's, so y to the 12th. That's a terrible 7. So I have negative 27 x to the 9th over y to the 12th. And that's all I've got for you. That's all I've got. So I'm combining a variety of different kinds of exponential problems, some with positive and negative exponents, zero exponents, taking multiple powers to other powers. I want you to be able to use all of these rules, specifically the negative exponents and the zero exponents, in simplifying exponential statements, and be able to simplify exponential statements that are taken to a power or to another exponent. So that's all I've got for you today. I hope that's helpful. Please reach out to me if you have any questions whatsoever. I hope that you enjoyed that as much as I did.